Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to satellite communication systems. Previously, we discussed some basic concepts related to gravitation and various parameters. Now, here in this video, we are going to apply those concepts to the actual implementation, how it comes into play when it comes to satellite technology. So here in this video we will be discussing the basic principle of launching of a satellite. Now there is a more detailed approach. Here I am going for the basic simple approach, okay, the simple concept in a very simple language. I will try to make you understand how a satellite is launched. So before that, we will be discussing the two important things that are required for the launching of a satellite. Okay, so before that, let us consider a situation. Okay, let us say we have a ball, okay, a volleyball or a football or anything. It has a certain mass, so we throw it up using some force with a certain initial velocity. The ball will reach a certain height above the ground, then it will come to rest and it will fall down back to the surface of the earth. When we increase the force, okay, when the force applied increases, the initial velocity increases, the height attained by the ball also increases. Okay, it keeps going up to more height, okay, more heights above the ground. Now suppose, imagine a situation, we give it such a velocity with the help of a machine or whatever external source, because we are not capable of generating that kind of force to generate that velocity. Suppose we give it such an upward velocity, okay, vertical velocity, that it escapes Earth's gravitational field. In that case, the ball will not return back to the Earth's surface at the same point. It will undergo movement around the curvature of the Earth, and depending upon the height and different parameters, the mass and everything of the ball, it will either hit Earth at some other point, okay, undergoing parabolic trajectory, okay, it will hit Earth at different points, or it will undergo a circular movement around the Earth. Okay, now the same principle is applied for satellite launching also. Okay, so here our first objective is to ensure that the satellite, it escapes Earth's gravitational field. So you imagine a situation now that there is a very tall tower, okay, a very tall tower, and the tip of the tower, the top portion of the tower, is outside Earth's gravitational field. I know it's impossible, but just imagine, okay, there is a tall building or a tall tower whose tip, the top portion, is outside Earth's gravitational field. Suppose we have an object on the top of that tower, okay. Now here we give it some velocity in the horizontal direction, okay. Here it is a different thing, okay. The object has already escaped Earth's gravitational field. It has escaped Earth's gravitational field. Now we are giving it a horizontal velocity, okay, a horizontal velocity. This one is about the vertical velocity, so that it escapes Earth's gravitational field. Once it has escaped Earth's gravitational field, we are giving it a horizontal velocity. Now If we apply a horizontal velocity, what will happen? The object, it will undergo parabolic motion, a parabolic trajectory. Now I have already explained in detail about the parabolic motion or movement of the objects in the projectile motion topic in the mechanics section, mechanics playlist. So please watch that video. There I have explained the projectile motion and everything related to that, all the parameters related to that. So here I will not go into the different parameters, mathematical equations, all that. Okay, so simply the object being given some horizontal velocity, depending upon the magnitude of the horizontal velocity, it will undergo parabolic trajectories. So if we give it a certain certain horizontal velocity, this first case, it will undergo this parabolic movement and will hit Earth at point A here. Okay, it will hit Earth at this point, a bit away from the foot of this tower, and this is considerable distance. Okay, now suppose we increase the velocity by a certain margin, then it will undergo a different parabolic trajectory and will hit Earth at point B. And again we increase the horizontal velocity, it will undergo a different parabolic trajectory and hit Earth at point C. Similarly, if we keep on increasing the horizontal velocity, a point will be reached where this object, it will escape Earth, escape hitting the surface of the Earth, it will miss hitting the surface of the Earth, and it will undergo circular movement, and it will move around the Earth in a circular path, in a circular orbit, and this movement will be stable. Okay, and that velocity which is imparted to the object outside Earth's gravitational field, the horizontal velocity, such that it escapes hitting the curvature of the Earth, hitting Earth's surface, and undergoes movement around the Earth in a stable orbit, that is called as orbital velocity. Okay, and the upward velocity, the vertical velocity or the velocity in the upward direction, which ensures that the object escapes Earth's gravitational field, that is called as escape velocity. Okay, it is called as escape velocity. So the velocity in the first case, the velocity in the upward direction, vertical velocity in the upward direction, which ensures that the object, it goes to such a height that it escapes Earth's gravitational field, that is called as escape velocity. And once the object has escaped Earth's gravitational field, the horizontal velocity given, which ensures that the object, it misses hitting the surface of the Earth and undergoes movement around the Earth in a circular path, that is called as the orbital velocity. So there are two important parameters which are required for a satellite launch. First one is escape velocity, second one is orbital velocity. So what happens is that depending upon the satellite, the design considerations, its objectives, at what height above the Earth it should orbit, at what distance from the Earth's surface it should orbit around the Earth, at what location it will be launched, depending upon all those things, suitable initial vertical velocity is given to the satellite. Okay, it is launched with the help of a multi-stage rocket. So here I'm not going into the detail. Here I'm saying this in simple terms. So what happens, that the satellite is given an initial velocity, a vertical velocity in the upward direction, such that it escapes Earth's gravitational field. Okay, the rocket is launched such that it escapes Earth's gravitational field, and this minimum vertical velocity with which the rocket or the object is projected vertically upwards so that it escapes Earth's gravitational field, that is called as the escape velocity. Okay, so the rocket is launched with such a vertical velocity in the upward direction that it escapes Earth's gravitational field, and that velocity is called as escape velocity, V subscript E. Okay, this vertical velocity is because of the exhaust gases. Okay, the exhaust gases, they impart the escape velocity. Okay, now once the rocket, it has escaped Earth's gravitational field, a suitable velocity in the horizontal direction, it is required to put the satellite into a stable orbit. Okay, to ensure that the satellite, it does not hit the Earth's surface and it orbits around the Earth at a considerable separation distance, and that horizontal velocity, which ensures that the Earth orbits, that the satellite orbits around the Earth in a fixed orbit, okay, a fixed circular path, that is called as the orbital velocity. Okay, so these are the two important things. Okay, so this is the orbital velocity and then the escape velocity. The escape velocity ensures that the rocket carrying the satellite, it escapes Earth's gravitational field, and the orbital velocity, the horizontal velocity, it ensures that the satellite undergoes a parabolic trajectory, parabolic motion, and it orbits around the Earth in a fixed circular path at a certain separation distance. Okay, these are the two important parameters. Now, as I said, multi-stage rockets are generally used for the launching of satellites. 3-stage rockets are generally used. So what happens is that at the liftoff, as I said, the exhaust gases, they build up a large upthrust, okay, so that the rocket accelerates upwards through the dense atmosphere in the minimum possible time. Okay, so it gives the rocket the exhaust velocity, the escape velocity, escape velocity. Okay, so once the escape velocity is imparted, the rocket, it escapes Earth's gravitational field. This is the first stage. So when the fuel of the first stage is exhausted, the exhaust gases, they impart the escape velocity, the vertical velocity in the upward direction. The rocket escapes Earth's gravitational field. Then the casing is detached. Okay, that portion of the component which provide the upthrust because of the exhaust gases, that gets detached. Then the rocket is tilted in a certain direction in the second stage, and then in the pure horizontal direction, here the total rocket, it separates itself from the satellite, and the satellite is given the required orbital velocity in the horizontal direction. Okay, and the horizontal velocity is given in such a way, as I said, that it undergoes parabolic motion around the surface of the Earth, and it misses hitting the surface of the Earth, and it undergoes movement around the Earth in a fixed circular orbit at a fixed separation distance from the Earth. Okay, this. Okay, and this movement, it is called as the fixed movement of the satellite around the Earth, and this is the objective of the orbital velocity. Okay, so in this, if we can summarize the whole thing, there are two important components, important velocities required for satellite launch: escape velocity, the vertical velocity in the upward direction, which ensures that the rocket carrying the satellite, it escapes Earth's gravitational field. Okay, the escape velocity, and the orbital velocity, it is the horizontal velocity which is given once the satellite escapes Earth's gravitational field, which ensures that it undergoes parabolic motion without hitting the Earth's surface and moves around the Earth in a fixed circular path. Okay, so these are the two important parameters which are required for satellite launch. Okay, so in the upcoming videos we'll be discussing them in detail along with the required explanation and mathematical formulation. Okay,